All right, first problem, chapter 25, is problem 6, and it reads, you have two flat metal plates, each of area 1 meter square, with which to construct a parallel plate capacitor. A, if the capacitance of the device is to be 1 farad, what must be the separation between the plates? B, should the capacitor actually be constructed? It's asking, should we actually make this capacitor? This is, we're going to use this problem to just review a few things, and then we're going to solve it. We have two parallel plates. And on one plate, we're going to have a positive charge. And the other plate will have a equal and opposite negative charge. We know that the E field goes from positive to negative in between these plates. Now, the first thing we need to do to figure out capacitance is we're going to have to use Gauss' law. And this is just a little review because on the test, you're usually going to get a question more like this than the one that we have for homework assignment. So Gauss' law tells you to put your Gaussian circle, it's not a circle, but we've got to encircle the positive charge. And when we do the integral, we're going to integrate from negative to positive. Now with that, we know that epsilon naught times this integral is equal to E dot dA equals Q and V final minus V initial equals minus the integral E dot ds. Now, this is uniform. The E fields will be uniform. And so in this case, so we have a uniform field, we can drop the integral. So we can say E sub naught E A, yep, dA, it was just an infinitesimal part of the area. We're integrating now. EA equals Q. And we can do the same here. And since we're going to integrate from minus to plus, we can just say V is equal, we can get rid of this minus sign, E times D. Now we know our Q is equal to C times V, which will go to C, capacitance, is equal to Q over V. Now we'll just substitute V and Q into this equation, and we'll have C equals epsilon naught E A over E D, E's are cancel, and that will go to epsilon naught A over D. We just did this little exercise because on your exams, you may have a circular capacitor or a spherical capacitor, and you start with these same techniques. If it was spherical for your area, you'd substitute the area of a sphere. If it was cylindrical, you substitute the area of a cylinder, and you would work it out in the same fashion as we work this, and you can solve it for spherical or cylindrical. Now the problem wants to know what would D be. So let's solve for D. D is going to equal epsilon naught A over C. And we'll just plug in. Epsilon naught is equal to 8.85 times 10 to the minus 12 farad meters. And we have the area given us in the problem as 1 meter square. 1.0 meters square, and the capacitance is just 1 farad. So the farads will cancel. One of the meter squares will cancel. We'll be just left with meters. And so D is going to equal 8.85 times 10 to the minus 12 meters. That's the distance these two capacitors would have to be separated using the parameters given in this problem. And we know that an angstrom, just getting down to the atomic level, is equal to about 10 to the minus 10 meters. So we wouldn't build this. We're probably not capable of building a capacitor that would be that close together.